right, this is the portion where we're going to explain the intended operation of our FPGA game and our actual implementation. The intent of the game is, as you can see, has the player number displayed on the left-hand side and the current count on the right-hand side. The game is supposed to toggle between two players until with each player choosing to subtract 1, add 2, or add 3, and the players go back and forth until one player makes the running total land on 21, which means that that player wins. You'll see in a moment we were not able to implement in time getting the player 1 and player 2 to switch, but we do have the running total, and you will see a win condition when it gets to 21. Buttons 1, 2, and 3 are supposed to subtract 1, add 2, and add 3, and the button on the top is the submit. So the player will select their intended entry and they hit the submit, and you'll see a light come up when the entry is input, and then they'll hit submit and the counter will change. So also of note, we were not able to get button 2 or button 3 working flawlessly, so at this time we'll start at 55, which is the condition the game loads into, and subtract 1 until we get down to the win condition of 21. We'll also cycle all the way down to 0 and show that it loops back up to 99 instead of going into negative numbers. So I'll go ahead and do that. So a player selects -1 and they hit submit, and you can see the counter goes down. 1, submit, 1, submit. Okay, so I'll rapidly load a whole bunch of these and get down to 21. And the players go back and forth until we get closer. And you'll see when I hit submit, we enter our win condition. And this is a W with kind of the loop, and a lowercase I and a lowercase n for a win. Now, with our intent, when we were supposed to display 2 boards, this would display win for the player who was the player at the winning time, and it would display LOSE for the player on the other board at the losing time. And also the RGB lights we were able to implement individually, but due to time constraints, we're not able to turn them on at the time of the win condition. All right, and that's it with the actual display of the board.
So in this part, I'm going to explain the organization of our modules. Overall, we have an interface module, processing module, and display module. At the top here, there's a port module, which would have been used to implement the connection between 2 FPGAs, but unfortunately, we weren't able to get to that part. In the interface module, you can see a game control as well as a display control that takes an input and spits out input into the processing unit and takes in 8 bits from the accumulator to check the conditions. In the processing unit, we have a logic conversion, an integrated module, an accumulator, and a decimal converter. Down here, we have an Accumulator, which combines 10 bits from the processing unit and 30 bits from the display unit into 40 bits for displaying the 7-segment display. And in this, we also have a RGB module for the light show.
So in this part, I'm going to explain the accumulator as well as the 8-bit adder. But first, on the left, we can see the game organization matches the PDF talked about before. The accumulator begins with the 8-bit adder, which is essentially 2 4-bit adders chained together, with the output of the first going into the input of with both outputs combining into the 8-bit output. Accumulator takes in 8 bits of input and outputs 8 bits as well.
Right, this is the display module section. As you can see, it's pretty much the same as what we did for lab 2, except we now have 8 digits that go out, and the digit control works the same, except instead of 2 bits controlling 4 digits, it's 3 bits controlling 8, with 1 hot encoding with a 0, a low voltage driving an anode, so this controls which digit is turned on, And then for the actual control of the digit, what's displayed on the digits, we just expanded from having your original hexadecimal 16 to 16 additional values, including H, J, and the W that we specifically wanted. So it has two halves that take the space of 2 digits and a null. Okay, here we have the game control portion. Basically, the player will select a value with 1, 2, or 3, which encodes it into a 3-bit number that is then passed to the processing module. A turn counter flip-flops back and forth between two values as a player hits the submit button. And then the display control simply accumulates bits together that says player 1 or player 2, depending on whose turn it is, and shows either nothing in the middle 4 digits or the letters win if the win condition has been met.